Do you want to learn how you can write resolvers for those nested fields inside your GraphQL queries? In this video, that is exactly what I'm going to be showing you how to do. Hi guys, my name is Sam with Complete Coding, but our aim is to make you into the best AWS and serverless developers that you can be. In this video, we're going to be looking at how we can add resolvers for our nested fields inside GraphQL. In the last video, we looked at setting up all of the base level queries, so we can get things such as the top level company information. But if we want to get something nested like Company.user, then we aren't able to do that at the moment. We're going to be looking at three different kinds of resolver. We're going to be starting with the default resolver, which gets a single item. We're then going to be looking at how we can get an array of items or a page of items. And finally, we're going to look at how we can use pipeline resolvers to resolve a series of commands, one after the other, if we have more complex relationships, as we do with our user to company relationship. Remember that if you learn something new in this video, then it really helps me out if you give it a like, as it helps YouTube know that you've enjoyed it and so shares it to more developers just like yourselves. So let's jump into the code and have a look at what we need to do. In the last video, we set up all of the base level queries. So query dot and then the query name. And in our mapping templates, we created a lot of like get group, get my user, get published posts, and so on and so on. And if we head over into our AWS console, we can go into our API. And if we search for queries, what we can do is we can do for example, let's say a get company. And on that get company, I'm going to pass in a company ID. And I'm going to ask for the company name and the owner ID. If we now run this, we get back our result exactly as expected. One thing we don't get back at the moment is any nested things. So if I select owner and I want the owner's name and user ID, we know that the owner's user ID should be the same as the owner ID. But if we now run this, we get a failed error saying we cannot return null for a non-nullable type. That's because if we go into our schema and we find the company that has an owner of user with an exclamation mark, meaning if we request it, it cannot be null. And if we actually want to find out how this is resolved, on the right-hand side we have our resolvers, and under company, if under owner, there is no resolver. For things like the company ID and owner ID, they are resolved via our original query, but our original query doesn't return the user who is our owner. So in this video, that is what we're going to be doing. We're going to be going through and creating the resolvers for any of the nested things. So in this case, it could be owner.user, or it could be Company.posts or Company.groups. So if we head over back into our code, what I've done is I've actually set up all of these. So in here, I like to have a comment just above this section, and then it's you need to put the type. Instead of the type being query, it is the name of the model that you are adding a nested parameter on, and then the field. So in our case, that is Company.owner, and this is going to be querying the user table. This is because there we have Company.owner, which is going to return a user. If we find that query in here, so again, it uses the default type.field. So if we find Company.owner and then .request.vtl, we can see this, and this might look very similar to something like getMyUser, which if I pull that up and query.getMyUser, pull that to up here as well, we can see that it's a get item with user ID, and in this case it's using context identity username, but we're going to be using something slightly different. Because this is a nested field, we can use the source, and the source is the model that this is coming off. So in our case, the user ID that we're searching for in the database is source.ownerID. And if we look at our GraphQL, source is the company, owner ID is an ID, and that should all map up. So if I now run SLS deploy, I'm going to deploy these new nested fields and we can test them out. So now that has deployed, if we head over to our console again, go into queries, and now run the same query again. So this time we are asking for an owner, and now we get the owner. This means that we're doing one query for the general company information, and then because we are asking for the owner, it then does a second query, this time on the users database, to get back those fields. Now this was one of the simplest kinds because a company has a single owner. So what we're going to do now is look at the next kind. And the next kind is a company having a posts page. So in this case, we need to go back and find our Company.posts. And here we are looking for Company.posts.request.vtl. So this will also look very familiar, as this is going to be almost identical to the request for get posts for company. So this is the nested one, which has all of these parameters. And if we scroll down and find get posts for company, what do you know? It looks exactly the same. The only difference is in Company.posts, again, we're using context.source.company.id. So basically what we're doing is we're saying query the posts table and say that find any post where the company ID equals the company that we are looking at. One other thing to notice, and one thing I possibly didn't explain very well last time, is this scan index forward parameter. So if you set scan index forward equals true, then it will return your results ordered based on the sort key or range key in ascending order. That means in our case they'll be sorted from the oldest to the newest. That is what we want in terms of posts, because the oldest post that you have scheduled is the one that is going to go out next. If we have a look at company.published posts, again this is going to look almost identical to the get published posts, but in this case the scan index forward equals false. because in terms of your published posts, you want the most recent one, so the one that has the highest date, to become first. So you want them to be ordered in the opposite way to the posts. So with this, we can also head back into our console and scroll down to our posts. And in here, I'm going to say that I want a single post, or the posts. And on the posts, I want the post ID and the content.text. If I run this, I have the company, which is here. I have the owner. I also have posts, which is then going to have an array of posts containing the post ID as well as context.text. As you can see, there are the 3 posts that I put in as mock data before, showing that this nested parameter of posts is working just as expected. So with the 2 methods I've shown, you can now get a single one-to-one relationship, such as a company has a single owner, but you can also get an array, such as a company has a list of posts, or in our case, a post page. So those 2 will actually do a lot of the schema nested fields. So if we have a look at our schema, those 2 methods will do posts, publish posts, groups, and schedules, as all of these have the same method, which is do a query based on the company ID for that table. This can also be used for things like on posts. So post.company is going to be the same as Company.user. It's a one-to-one relationship. If we go down, so published posts.group, again, a single published post has a single group. And for all of these, that is pretty similar. As you're going through and creating all of your nested resolvers, you may find that a lot of them are very similar, and some of them are even identical. For example, in my case, there's a lot of places where a model has the property of group. So company has a group. As well as that, if we look at our schema, we see that a post also has a group, a published post also has a group, and a schedule also has a group. All of these are connected because they have a group ID on them. So what we can do is we can make our querying, or make the work that we have to do, a little bit simpler. Inside my appsync.api.ts, if I go and find here, so posts.group, instead of creating a post.group and a published post.group, I've actually created something called model.group.request.vtl. And if I find that in here, so model.group, so this is doing the query where we pass in a company ID and a group ID to get the item of group. And in all of those cases, the query would be exactly the same. So instead of duplicating this exact file with 8 different names, I've given it a single name, and anywhere that we need something.group, I've just manually set the request and response to be model.group.request.vtl. I've actually done the same thing with company, because both posts, published posts, as well as groups and schedules all have a company field on them. So again, I created model.company.request.vtl and just reference those. This is a nice little tip to keep the number of mapping templates down a little bit and save you from repetitive work. The one where things are a little bit more advanced, shall we say, is the users. A user has a list of companies, and those companies are done through the relationships table. That means that we need to say a little bit more than just get companies where user ID is on the company. With the relationships, we need to do something called a pipeline. So if we scroll down to here, I've added a new query, which is User.companies. But this time, we have to have a kind of pipeline. We then also have a functions, which is an array containing functions that we want to execute. If we actually head over into the Amplified docs, we have a nice diagram showing us how AppSync pipeline resolvers actually work. So when you get the GraphQL request, there is a template which wraps this whole thing together. From that template, you then run function 1. This has its own request template, queries a set of data, and then transforms it exactly as we have done with every other request. The difference here is that response is then passed into the next request. That request again has a request template, can query a data source, and then return the response. The difference here is this response template has access to the response of this data as well as the response from the previous function. So if you need to combine data sources, pipeline resolvers will allow you to do that. After all of your functions have run, and you can have as many functions in a row as you want, there is an after template which basically puts it all together and then is sent as a response to our GraphQL request. So in our case, we are doing a get companies followed by a hydrate companies. And that is because in our schema, with a user, we can do a query on the companies using the relationships table. So what we're going to do is if I find my resolver for this, which is going to be same as always, it's going to be just in this case, it's just going to be the name. So if I find get company, there we are. And in here, I've got my default checking of the length, but at the top, I also want to check the user ID. So if someone's passed in a user ID, then we want to set the user ID to that argument. But if they haven't passed in an argument, I'm going to default to using the identity of the querier. And this way we can use this for both get my companies, or we could use it for get the companies of a specific user that I am requesting. If we go down a little bit, we can then see that this is very similar to most other queries. We're querying on user ID, passing in the user ID, and that is everything. If we then go into our response, we're returning basically a relationships, which is going to be an array of relationships, and those relationships are going to return and contain the ID of the company that this user has a relationship with. If we go into AppSync again, the next one is going to be hydrate companies. So now that we have a list of company IDs, we want to basically query the companies table, hence why the data source is companies, and populate the actual full companies object. So if we go and find our hydrate companies, there we are. And in here, we have some new logic. So the first thing is we get the previous response, which if we look here, the response from here gets passed into our request template. So context.previous result. So whatever is returned from the get relationships will be here. And we're looking at the relationships. If the size of that array is 0, then there's no point querying the database because there's no relationships. There are no companies. So we're just going to do an early return where we say that the companies is an empty array. If there are relationships in that array, then we want to create a companies array, which is going to be an array of queries. And for each relationship in that array, we want to create a company query object and then set the company ID to equal the relationship.company ID. So that is taking the relationship from the previous query and then setting the query on the company's table to be that company ID. Here we're then adding this company, and we have to use this DynamoDB map to map values in here because of the way that the DynamoDB batch query or batch get item works, and set that to be a query. If we now go down, we can look at the actual query. So here we're querying saying the keys need to be the JSON of companies, and then we're going to be querying that on the companies table. Now, because we don't actually know the ID of the companies table when we are writing this, as AppSync creates us a relatively random ID at the end of our table name, we actually have to reference it here. So to reference it, we actually need to do something called substitutions, which if we go into the AppSync API and all the way down to the bottom of the file, I've added this thing called substitutions. And substitutions are a way of passing values or variables into your VTL templates. So in this case, I'm passing in the key of companies table, and that is going to reference the deployed companies table so that we get the correct name. So all you need to do is make sure that this value here is exactly the same as the value within this $ curly brackets. So that's going to do our query, and then in the response, what we're going to do is we're going to say that the companies equal utils.toJSON, which is our standard way of formatting it as JSON, and then it's going to be context.result, but because this was a batch, it's going to be .data and then the .table name. So again, we're going to be using our $ curly braces with the substitution value in here, and that will return our companies, which will fulfill our request. The last part of our pipeline resolver, if we go up, is the bits at the very start and the very end. So the before template and the after template. So here we have to define a request and a response. And for this kind of pipeline where we're not really doing anything before and we don't really need to do anything after because everything is handled within the functions, we can just have a very simple pipeline. So here we have the simple pipeline request.vtl, which is just an empty pair of braces because, as we've said, we don't actually need to do anything at this point. And the response is basically just saying, take the result from the final function and pass that back to the user. So in our case, the response from hydrate.companies, which is an object with that companies on, is what we want to pass back to our users. So if we save all of this again and deploy it all, then once that is finished deploying, we'll be able to test doing our pipeline resolvers. So now that has finished deploying, if we head over to our console again, and here we can see that we have a single company ID, but if we want to change this and say get my user, and from get my user, I want to go and say that I want the name of my user and hit request, we'll get that back as expected. If we open up .companies, we can say in that companies array, I want the company name and the company ID, and hit run. Here we can see that this user, my user, has an array of one company, which is the my test company with this ID. We can take this a little bit further, and we could even say that on that company I want to get the posts, and on that post I want to get the text. And if I run this, we then get the data for the user, we get an array of companies. For each of those companies, I'm going to get a post, and for each of those posts, I'm going to get context.text. You could go even further and say that for each post, I want to get the company name. And if we run that, we can see that each post has the context and company name. And this is one of the great things about using GraphQL, is that you can have this nested nature. And once you've defined all of the resolvers for each of the nested fields, the user can actually go as deep as they want through all of these steps, which is honestly quite a nice setup. In this video, we've done quite a lot this week. We've set up our resolvers for every single one of our nested fields. This now means we can go through the query structure and add multiple layers of requests and nested fields. This is great as this opens up the full power of GraphQL and means that in terms of querying, we're actually done with GraphQL. That means in next week's video, what we're going to be doing is actually looking at the mutations and how we can add data to our AppSync API. So thank you again for watching, and I'll see you in next week's video.